Central facility. He's getting pretty good pictures on you.
We've come a long way in weather forecasting since the early balloon launching days, thanks mainly to weather satellites. Just 15 years ago this month, NASA launched the first Tyros weather satellite from Cape Canaveral. The views of Earth were pretty rudimentary compared to today's high-quality pictures, but they proved that routine global weather observation by satellite was possible. With each succeeding one, these weather sentinels have become more and more sophisticated. Here, the synchronous meteorological satellite. 2 are already in orbit, with a 3rd scheduled for launch this fall. Besides transmitting cloud cover pictures every 30 minutes, day and night, SMS can receive and send environmental information from thousands of manned and unmanned data collection platforms, located at sea, in rivers, lakes, and on land. The synchronous meteorological satellite pictures are made into film loops daily at the World Weather Center near Washington, D.C., to show cloud movement over oceans and land masses. Meteorologists are hopeful that this kind of information will give them clues to the weather conditions that, for instance, cause tornadoes and other fast-moving weather systems. Weather satellites. Over the past 15 years, they have returned more than 2 million pictures, provided advance warnings, and allowed no major storm anywhere on the globe to go undetected. These model airplanes have something in common with these Rio planes. They are all part of a NASA research program to learn more about vortices, tornado-like patterns of air that trail behind the wings of airplanes, causing varying degrees of turbulence. Dave Scott, Acting Director of NASA's Flight Research Center in California, explains.
The vortices are dangerous because these bundles of energy, as they follow behind the aircraft, leaving a wake, have the capability of turning over smaller aircrafts as they approach a landing. And because of this, we have a great deal of concern that many accidents can be caused by the vortices or these bundles of energies as they attempt to turn over an aircraft.
While all aircraft cause vortices, large heavy jets such as the 747 and DC-10 create the more serious problems. Air traffic density around major airports adds to the severity of the problem. Because of the many aircraft coming in for a landing and the need to sequence one plane behind the other, aircraft are routinely separated at safe distances to avoid the trailing vortex problem. However, this often results in increased fuel use and traffic delays. Smoke generators mounted on the wings of these planes by NASA researchers make it possible to see and investigate the whirling air patterns. The research has shown that by adjusting wing flaps at different angles and by making various design changes, the intensity of the vortices can be substantially reduced. This kind of aeronautical research today may very well result in even safer, more convenient flights in the future.
This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration.